I'd like to introduce our next speaker, David Haviland. David has worked in flow cytometry for nearly 4 decades, beginning with the EPIX 5 systems during his graduate training in the mid 1980s. His doctoral research focused on T cell biology, including the molecule now known as CD44. He completed his postdoctoral training at Washington University in St. Louis, where he studied complement biology and inflammation and reported that some chemoattractant receptors are expressed on cells incapable of chemotaxis while also supervising EPIX Elite and XL instruments. David later joined the University of Texas Houston Institute of Molecular Medicine, overseeing multiple cytometers before transitioning fully into core management. Since 2011, he's served as director of the flow cytometry core at Houston Methodist Research Institute, which he built from the ground up. He is a longtime ISAC member, and he served on ISAC Council from 2014 to 2018 and continues to focus on education, data analysis, and best practices in cytometry. Thanks for speaking for us, Dave.
Okay. We'll see how this goes. Now, this is obviously a change of venue or topic, so to speak. I'm not going to talk about any math. There's not going to be any compensation or anything like that. This is a complete change of venue. It is my hope that by the end of this talk, you're going to be somewhat irritated, if not slightly angered about what's going on out there, because it's real. Okay, now, what do I do for next slide? Perfect. Okay, where did all this come from? So basic outline for this talk. Where did all this come from? We're going to talk about what is expected of scientists and institutions. I'm going to talk about examples of data manipulation. Data manipulation can go anywhere from ignorance all the way to the other side of the spectrum of outright fabrication and falsification. I will show some of that. The dreaded cell line issue. This too, much like Dave Novo's talk, was whittled down from 45 minutes to 20. So I hope I can push it all through. And then basically, what are the cores to do here in this situation? So before we dive in, just reflect on your own experience and your own careers. Do you recall the first time in your career you heard about scientific fraud or misconduct? I can. I was in my second year of graduate school, and the guy that taught me virology at UC San Diego was getting fried. He was doing things he shouldn't have been doing by NIH rules. He was supposed to work on this virus. He decided to work on that virus because he was that far ahead of the game. Needless to say, I think he was teaching grade school back in Scotland now. So when it comes to rigor, reproducibility, and data reproduction, you can see it better without the glasses. What differentiates errors of ignorance, sloppy negligence, ethics? Is this control good enough, or in some cases, no controls? Data being published in multiple manuscripts, and outright data falsification. This is one slide I'm going to spend a little bit of time on. How bad has it become? This is still current as of June of 2024. This covers authorship, affiliation problems, duplications, ethical and legal problems, unreliable results, data plagiarism, falsification. And you might see some of these are going down. So you're going to look at me and say, David, what's the problem? I can tell you what the problem is. It's called collateral damage that has to get measured through time. Now, I'm just picking on random people. If Carla, Meredith, Rui submit a paper and they're citing my paper and my paper has a problem, it depends on the level to which they are citing it. If they're citing it, yeah, we agree with that conclusion. Here's ours. There's not going to be much problem with their papers. However, if they cite my paper and there are major issues with my paper and they turn around and are using my paper as the springboard for hypothesis for their work will now become in doubt. How long does this collateral damage assessment take? Anywhere from 15 to 65 months. So it is pretty well thought that these curves are going to start going up as they have been, as you can see here. It only gets worse the deeper the collateral damage is and the more a particular paper is cited. I'm not going to say anything other than country, total publications, retractions, proportion of retractions per 10,000. Just run your eye down the columns and you're going to see what you're going to see. It's pretty widespread, unfortunately. So how much fraud is out there? This has not been updated. I don't think NIH has decided to have the gumption to try to reissue this survey, but 3,200 researchers funded by NIH responded to a survey. 1.4 admitted to plagiarism, 0.3 admitted to falsification of data. 15.5% say they had changed the design methodology or the results in the study because of pressure from a funding source. Not cool. So where did all of this end up coming from? Recent policy changes, rigor and reproducibility, and sponsored research projects. These series of policies were announced back in fiscal year 15 and 16, and then up until now, the current, as I understand it, the current PHS form from 2020. This is an active link. Oh, and if I didn't say, you're more than welcome to take pictures through this, and this will also be up on the YouTube. Enhancing reproducibility through rigor and transparency. This is a compliance document of how to get things going. So I need increasing attention from the ability of researchers to replicate other people's results. I think that came out a number of years back. They were saying like 60 or 50 or 60% of most immunological studies could not be reproduced. Well, that's the part of what has to change. Need to desire and ensure proper stewardship of the research dollars. So the best general practices, responsible code of conduct, laboratory practices, SOP, that kind of puts the onus on the cores to have that up to speed. Reduce and eliminate conflicts of interest. I have known a couple of professors that have been terminated because of conflict of interest. Strive to reduce the research misconduct. Cores have to educate clients. That's something really big that ABRF is pushing out, is to help have the cores be responsible for client education because the PIs aren't doing it. We'll gloss on that through the talk. Data management, I'm going to talk about that later. I need more room on this mouse. Investigators and their staff have to keep adequate records, detailed lab notes, and record retention. We're going to talk about that. Storing the original data in its original form for years, not just a few years, but for many years. Okay. A lot of words, you don't have to read them, but authentication of biological resources is new as far as the NIH requirements. You got to tell them what you're doing. You're going to have to talk about your SOPs, your antibodies and reagents. You've got to list them, clone vendor cells, verification of cell lines. How are you doing this? Does your institute require it, or what? I say that because Methodist tries not to get in a researcher's way, but if I'm going to give a cell to Meredith and we're in the same institution, she has to fill out a material transfer and additional paperwork. Where Methodist has put enough paperwork in play that Meredith will sit there and say, it's easier if I order the damn cell from ATCC and buy it myself. That's kind of what they're steering you toward, because there were rumors of jerkats and other things being passed around NIH decades and decades ago, and one guy was savvy enough to realize that jerkat wasn't doing what it was supposed to be doing and found out it was HIV integrated, and they were handing it around just in a flask, hand to hand, with no gloves. So yeah. In short, everything you do in a grant has to be explained. So this, one of our management officers gave me the summary page from one of the investigators' grants on my floor. He's listing all cells that he's using, all the antibodies he's using, what's going to happen to the cells, what the antibodies, how they're going to be worked on, ELISpot, that kind of thing. And if you've had the privilege of publishing papers, you know you have to list every bloody clone you use in the paper now. Papers are no longer just the results and discussion and the data. That's it. It just keeps going. Part of that review process, they're going to review the scientific premise of the proposed research. Is it sound? Are the experiments rigorously designed? Are you considering key relevant biological variables when you're presenting the grant? And authentication of key biological or chemical resources. If any of these are lacking science aside, the grant is probably under the table on its way to being triaged. If they get a bad smell or they get a bad whiff of you're not descriptive enough on what you're doing, the grant's probably not going to make it. Core and research facility role, you got to work with the investigators to develop a plan for their proposal, advertise the availability of your core services, that you've got SOPs out there. I'm still revising mine. Core operation instrument QC, that's where we help the client by keeping the machines up and going. provide boilerplate languages for support letters as they need, provide FAQs for researchers. In my case, I support, I'll give them letters for their next grants, and help them with data analysis to a degree. I won't get into the actual aspect of core operation, but if Meredith came to me, sure, she gets a half hour free. If she wants me to take an entire afternoon, okay, then she might be on the clock. So the key point of the slide, though, communication between the sponsoring research organization, PI core, lab financial manager, and administrative assistants, they all have to be talking the same language and all be on the same page. What we don't want is somebody who's, no, I can do it all. I can do all my own bioinformatics. I can do all my own statistics. I can do all my own DNA analysis. To some, in my 30 plus years, that's usually a red flag. Not always, but usually. Examples of data manipulation and what is being done. Screening image-based data at Rockefeller University Press. Image manipulation is behind some of the most highly visible cases of scientific fraud. Travis is going to show you some in the next talk, so I'm only going to have one slide of fluorescence. Pre-screening images is now a commonplace at journals to prevent errors from entering the literature and trying to preserve the scientific integrity of the publication. In 2002, the Rockefeller University Press journals began screening all images based on data after the editorial acceptance, but prior to publication for signs of manipulation. So some 4,000 figures are screened per year by the journal. A third are flagged by screeners. That's over 1,300 figures. Approximately 1% are serious enough that Rockefeller University Press is forced to revoke the acceptance of the manuscript. Think about that a minute. Detailed guidelines, they have them all put out here, which develop into a 10-part blog for the screening process of how it's done. But I'm going to say, wait a minute, who are these screeners? They are graduates of college in graphic arts. They don't know the difference between a flow cell and a pipetter, but they know Photoshop, Adobe Illustrator, PowerPoint, and presentations like the back of their hands, and they can tell you how many layers have been put onto a figure to, in the investigator's view, make the data look pretty. In our view, what are they hiding? So there are technical reasons for limiting these screenings. Resolution, quality of the screening can only be as high as the original supplied data. Lack of originating data, failure of adequately plan for storage and archiving, supporting data. Sometimes you'll ask the investigator, where's the figure? Oh, I don't have it. You just have to work with the one I gave you. Duplications, usually identified by eye and usually limited to, but not always to the same manuscript. Largely limited to blots, gels, and microscopy, but not exclusively. I will show you where it does show in flow cytometry, since this, of course, after all, is a flow cytometry conference. Individual images are manually examined in Photoshop and Illustrator, and they're flagged due to background manipulations, duplications, splicing, overly adjusted contrast. And while they do not comprise the majority of cases, they can or cannot sometimes alter the interpretation of the data. Usually it can be resolved by having the investigator submit the original figure, and then Rockefeller Press makes the appropriate adjustments to make it happen, rather than relying on the investigator to do it. So more challenging cases are where significant changes are made to the data, where these things can removing data, adding data, and I'll show that to you. They investigate it with corresponding authors, and then it's whether or not that acceptance has to be revoked. That puts them in a very hard spot. I don't know if other journals are doing this, but that puts them in a very hard spot, because now they're forced with having to contact that PI's institution and saying, we have a problem. Okay. I am somewhat familiar with masks and layers in Photoshop, because in the off hours, I like to image the moon. So I will use Photoshop for this from a single frame video, and through using a number of masks, I can bring out quite a bit of highlighted detail. So I'm fairly certain I kind of have experience when it comes to masks and what you can do with it. So you look at some real data of some gels, and you find, and I'm going to roll through these, a lot of these are Southerns, Northerns, Westerns, EMSAs, and things like that. This figure was originally submitted, and it raised doubts at the University Press, and they said, show us the original one. Oh, there's a little thing in there they don't want you to see. So basically, they burn these in, but dodge that out so it's not there. You come over to this side, over here are the original images, here are the manipulated images. Where in the Sam Hill did this come from out of here, other than burning it in, which you can do in Photoshop or Illustrator, or the real doozy is, okay, this was here, how do we get this one out of that? Seriously burning this in. So what people will try to do to get their point across is crazy. These are common examples that are often on the net where basically, oh, this shows what I want here, but I'm going to duplicate it and flip it over and use it in the same figure by cut and splice. And now that's made even easier. In days past, you had to get the print, use a paper cutter, glue it into place. Now you can do this with Adobe Illustrator and flip things around. So a lot of this, some of this, you might see these little nubs right here and here. That is what tipped people off. Wait a minute, this could be a duplication. Fluorescent microscopy, again, not to tread on Travis, but here are some pictures here. The researchers want you to know, oh, this is really significant. We're highlighting this, but when you come back, when they reconstruct it from the original file, there's basically nothing there. And the same thing over here. These are highlighted really, really well. They burned these in really well to highlight them out. So the point is they're starting to amplify noise. Okay, flow. I know you're all waiting for that one. This is the biggest classic case. 1997, Luke was rubbing elbows with Abdul Abbas. That name might ring a bell. He wrote one of the seminal immunology texts that's used in many in today's classes in graduate schools. And he was also rubbing elbows with Nobel Prize winner David Baltimore. He published a number of papers from the late 90s to 2006, but he was reported by former mentees that parts of particular flow in Western blots were being manipulated. If you look somewhat carefully, now you can take your two parameters and you can dial in and out the number of events you want to show. But actually, this plot and it is rumored to be this plot are identical. And those of you really savvy at looking at your two parameter plots can start chasing dots. I mean, we get good enough at this, we can look at a QR code and know that it's different from that QR code. That's what two parameters do for you. And there's some that are duplicated down here. He did this enough with 5 submitted grants and 10 manuscripts were all found to be in error, and the collateral damage talk that I started with in the beginning was extensive for this work because he was being highly cited. 7 papers that were published that had to be retracted, and basically, of course, that ended his career. Something down to home, you got this 2-parameter plot. If you really want to know, this is the 6-color gating experiment that comes with every version of Diva, I believe, except for version 9.6. So I'll bet 80% of you have this on your machines at home. I have tripped people up when I said, here, take a piece of chalk or a whiteboard and draw me the 2 single-parameter forward scatter, side scatter, single-parameter histograms from which this would be derived. Because everybody in this room hopefully knows, that this is 2 parameters put against each other and you're looking at them from the top down. But I have tripped people up on this, and the 60, 70 plus papers I have reviewed for Journal of Immunology alone, I got into it with an associate editor who I was telling the other reviewer did not know how to interpret these. Most of your reviewers, whether they're ad hoc, assistant, or associate editors, I've even come across associate directors of institutes who do not know how to interpret these. But everybody in this room knows you can get them all working this way. So you know more than most of the editors. Little pop quiz. This one was dropped into my email box after an inquiry that I sent out to Purdue. All these little hooks. Plagiarism? No. Falsification of data? No. This is probably more just being sloppy. Hopefully everybody in this room can recognize this as just simple lack of compensation being applied, and that's all it is. This should be flagged in the review process. Underscore. But as you can see in the bottom, blood 2010, it's printed. A lot of it slips all the way through. Where's the area of responsibility? Investigator, operator, PI, all the way up to the reviewers. A lot of your reviewers don't know how to interpret the data. And this scares me because what do they do when they see Tisneys? Really? What do they do when they see Tisneys? Do they know what the hell they're looking at? They go, oh, pretty cauliflower, except you don't know. So as stated, most of the time the journals can get the issue resolved after establishing a dialogue with the investigator, we hope. The problem is when the journal editors have to decide whether or not, as I said, I kind of took the meat out of this slide, to establish contact with the Institute. So what drives fabrication? Obviously the motive, the major publisher parish provides quite a bit of motive, what they call the triangle fraud. Opportunity, I control the data, I can easily change it. My theory and reasoning is sound, the data is wrong and skewed. How many times have we come across people that will want the data to fit their hypothesis rather than letting the data tell them what's going on? I personally have lost count. Real fast, cell line saga nightmare. This continues to this day. Cell lines provide very simple models for biochemistry, cell biology, all the way down the list to gene therapy. It is a long-standing problem all the way back to the 70s. It started. UC Berkeley genetist, among other things, was identifying cells at the National Cancer Institute, and he started seeing things he didn't like. 1967, first reports of contamination. 1974, I was in the middle of high school, okay? Report 20 cell lines most commonly used for cancer research. 9 of them were already cross-contaminated with HeLa. It only gets worse. Over the years, hit lists of cells started cropping up. The NCI 60 they thought was a golden altar of cells you could use for cancer research, but it turned out some of these cells, MCF7, MCF780R, are in fact not related at all. MCF7 is a breast cancer cell line, the ADR one is an ovarian cell line. These two nervous cell lines turned out to be identical. The MDA metastatic breast cancer here is identical to one called M14. My favorite one that I came across personally, COS1 and COS7. They're 2 separate cell lines sold by ATCC. You grow them, they are completely different cells. The COS7s are very craggy, they got a rough edge. The COS1s are very smooth and elegant, but folklore would have it that 30 years ago, someone of Hungarian descent was carrying the COS1s, and Hungarians tend to make an exaggerated upswoop when they make their ones, and somebody else thought it was a 7, and the lines had been basically separated ever since. Now, it's one of those, is that actually true or not? I don't know, but you know, if the legend works, the legend can become fact, you know. I had a lot more slides of that I had to get out of here, but a lot of them, a lot of cell lines are cross-contaminated, and this is why grants and papers are actually asking for cell identification that you can do through the terminal repeats. So it's a colossal mess. NIH early in the 2000s actually did not want to do it, did not want to deal with it. They were punting the ball. But journals hesitate to assert authority. They said, this isn't our responsibility. Scientists in the lab are saying, not my lab, but my cells are COS1, they're COS1. And we know how that goes. Best practices had not been established by late 2008, NIH started endorsing cellular phenotyping, which is now somewhat mandatory in most institutions. For a while, I think Anderson offers it as a service. We have it as an internal thing here at the house, at Methodist. Journals requiring cell authentication. The list is not extensive, but I couldn't fit much more on the slide. Hopefully the journals you submit to require it. So winding up, based on conclusions, I've got some food for thought here. You've got to establish and maintain strict SOPs in the lab, establish training, double check data sets within feasible. Ellie and I will periodically check data sets. I'll look at them. If somebody's trying to do cell cycle by region analysis, I will actually grab their data, run it through FCS Express cell cycle program and send it to them and their PI and say, this is how it really needs to be done. Authorship, when in doubt, forbear. I've had one person I had to have an argument with in the hallway who said he didn't need controls. He didn't need single color controls for his multicolor experiment. He could figure it out all in FlowJo. I said, please do not cite the core in your publication. I come across that even still. Who does the data belong to? That's a $64 question. Backup securely, core staff only. Backup preferably in the original format. I'm going to tie up on that too. At the institution, who owns the data? What I really need is a picture of a very piece of thin ice or somebody falling through it. Your PIs think they do. Your Office of Research Integrity is going to tell you the institute owns the data because the money is given to the institute is awarded to the investigator on behalf of the institute. So the institute is going to sit there and say, we own the data. So I've checked with my Office of Research Integrity and they say, how long do you want me to keep the data? And they said, for the life of the core. So I have data in my core from PIs that left 5 years ago. The data's still there if there's ever any problem. So because the institute provides the administrative overhead, that's part of the reason they feel they own it. So what does this mean for the cores? The cores have to store the data for how long? I think NIH was saying 5 to 7 years. How long has the PI been there? Again, I've already said Methodist wants me to keep it there for the life of the core. I have most experiments, shy of an incident with one investigator. I have most experiments since my core opened in 2011. Now, here's the fun thing. In what form should that data be? As close to original form as possible. I think Travis may tell you the original TIFFs and flow experiments in the investigator's hand. The original form of the data will depend on the type of core and the type of the machine. Most of my instruments are DIVA based, although the Aurora also does everything, generates everything in experiments. I do not keep FCS files. I only keep the original experiments. If I give, I'm not too far away. If I hand FCS files to Rui, Carla, and Meredith and say there's something off with this data, believe it or not, they're going to make an error. And that error is they're going to apply best practices to an analyzed data that's in doubt. The best thing is looking at the original data, and there you can go, is it fabrication? Is it negligence? What's going on? Did they try to get their percentage of gamma delta T cells out of a neutrophil gate? Was it something innocent, or were they really just screwing things up? That's where you've got to go. So then you throw in, where are we? Monday's discussion with Peter Hotez about public skepticism in science. Science is being vilified. You take this battle plus everything about PI arrogance and how data is worked on. This is why we got the problem we've got. And we all just have to keep fighting the good fight. And for that, I thank you for your time.